Hey guys, welcome back. This is topic 9, part 4, I believe. And now we're going to learn a new word, variations. So, what are variations? Well, they're equations that relates one variable to another by multiplication, division, or both. So, there are mainly two types. There's direct variation and inverse variation. So, in direct variation, the questions it says that y varies directly with x. So y is right here. Varies directly with x will be equals k times x, and k is some constant number. Okay, that is the one that doesn't change no matter what. X will change, and so does y, but k will stay the same. There's inverse variation where it says y bears inversely with x. The equation for that is y is equal to k times 1 over x. So instead of x, it's going to be 1 over x. And k again is a constant number. In some questions, instead of saying y bears directly with x, it's going to say y is directly proportional with x. And in some inverse problems, instead of saying y bears inversely with x, it will say y is inversely proportional with x. So they switch around sometimes. They use in your test they will probably use this. So take note of this. Essentially, if it says direct, we're doing direct variations. If it says inverse, we're doing inverse variation. No matter what. Okay, that's pretty much what will our keyword, I guess. So if it says direct and whatever words it follows, you know we're doing direct variation. If it says inversely, we're doing inverse variation. Okay? So let's talk about some examples of direct variation and inverse variation so you guys get to see what they look like. So in direct variation, there's y equals to x. So where is k in that? Well, if you look at this carefully, it's basically the same as y is equal to 1 times x. 1 is our k, and x and y will be the numbers you plug it in. And then same thing with inverse variation, y is equal to 1 over x, where's the k? Well, it's going to be 1. This is going to be y is equal to k times 1 over x. Y is equal to negative x is, you can translate to that as y is equal to negative 1 times x. And in inverse is y is equal to negative 1 over x is the same thing as y is equal to negative 1 times 1 over x. And pretty much the same thing with this one, okay? Y is equal to 2x, 2 will be our k, y is equal to negative 2x, negative 2 is our k. Y is equal to 1 half x, 1 half is our k. And you can see it on the inverse side. So direct variation can have, your k can be fractions, okay? That's okay. It's okay to have fractions in your k. I had students that just because they got k when they got fraction for their k, they got in their problems, they start redoing it and they believe it's going to be a whole number, but not really. It can be any number. You can convert this fraction to decimals, but I prefer having fractions because we can simplify easier when we're multiplying x. So again, k can be fractions. Okay, that's what you get here. Okay? and k can be 1 and -1. So let's have some problems. Oh no, let's talk about why is it called direct and inverse variation. So here's the answer. Let's say we have a direct variation, y is equal to 3x, our x's and our y's. So let's say you input 1 in your x, right? 3 times 1 will give you 3, as shown here. Now let's increase that by 2, and 3 times 2 will give us 6. Well, 2 is twice as big as 1, right? So in direct variation, our y should be also twice as big as our original y, okay? You see it? So it increased by 2 times, our y also increased by 2 times. Now let's say we had 1/3. 1/3 is a third of 1, obviously. So if you plug in 1/3 into your x, you're going to get 1. So 1/3 is a third of 1, and 1 is a third of 3. So if you go big, if your x gets bigger, your y gets bigger. If your x gets smaller, your y gets smaller in direct variation. So in inverse variation, you're thinking something is already right, and let's clarify your thoughts on that matter. Well, in the inverse variation, let's say we have y is equal to 2 over x. Again, this is our x, this is our y. Our x, if you plug it in, you'll get 2. If we increase our x, let's say 2, if you plug it in, you're going to get 1. So our 1 is increased, our y decrease. Now let's say we decrease our 1 to 1/2. Our y increases. So our x decrease, y increase. So it's kind of inverse, right? One goes up, one goes down. Unlike in y, if one goes up, the other goes up also. So that's why they're called inverse, okay? So in solving variation problems, let's have some steps. So again, first thing first, you identify the type of variation you're going to deal with. Is it going to be inverse or going to be direct? Why does that matter? Well, because we're going to write the formula. That's why it matters to determine what variation we're going to deal with. And then we're going to substitute the first two given values. In this type of question, you guys are given 3 numbers. The first 2 will be plugged into our formula, and that formula we'll use to find k. And then once we got that k, we're going to use our third number and our new k, plug it into the formula, and find the unknown. So let's have an example on that. So let's say we have m varies directly with n. If m is equal to 56 when n is equals to 8, find m when n is equal to 11. Again, I use different what do you call that? Different variables, but this is your y, this is your x, just in case you don't know. So let's first identify the variation type. If you look at this closely, it says directly, right? So it's going to be a direct variation. So that means y is equal to k times x. Or in this case, since we're using different variables, it's going to be m is equal to k times n. Now, second step is substitute the first 2 given values. In this case, m is equals to 56 and n is equals to 8 into the formula. M becomes 56, n becomes 8. You kind of see that k is unknown, right? We don't know what k is. But we're going to use these 2 numbers and we're going to solve for k. How do we do that? Well, we isolate k by dividing both sides by 8, and you're going to get 7 is equal to k. Now we're going to substitute this k and the third value, n is equal to 11, into this formula. Again, into this formula. We're not going to use this again. We're not going to use this. We're going to use a blank formula. We're going to plug it in. K will be 7, n will be 11. And then just solve for the unknown. In this case, the unknown is m. M is equal to 7 times 11 equals 77. And that's basically it. So let's have another one. This time is y is inversely proportional with x if y is equal to negative 1 over 5 when x is equal to 15. Find y when x is equal to negative 3. So in this case, the keyword is inversely. So that means it's going to be inverse variation. Just because it's proportional doesn't mean we're doing proportion, we're going to do variation. Our keyword here is inversely, okay? Again, variation and proportional will probably switch around on your test, but a lot of times in your test and in your math classes, in your other math classes, but they're basically the same, okay? You'll later learn that. But variation proportionals are uh, uh, nearly the same, I say, but I'm getting off topic. Let's solve this problem. It's inverse variation, so it's going to be y is equal to k times 1 over x. So substitute our first two numbers. First two given, y is equal to negative 1/5 and x is equal to 15. So if you substitute that, you'll get this formula. Negative 1/5 is equal to k times 1 over 15. And now we want to isolate k. So we had to get rid of that 1 over 15. To do that, I say multiply both sides by 15. This becomes 1, so you're left with k on your right hand side. Since we multiply this side by 15, 15 times negative 1 over 5 is negative 3. So our k is negative 3, and we're going to substitute negative 3 equals k and x is equal to negative 3 into this formula to get y is equal to negative 3 times 1 over negative third, which is 1. Pretty simple, right? Just substitute, find k, and then substitute again, and then find the unknown. But sometimes it's not going to look pretty as this, okay? Sometimes you guys are given word problems, but basically the steps are the same. So let's say we have an example. The weight of an object on Earth is directly proportional to the weight of the same object on the moon. 200 pounds object on Earth weigh 32 pounds on the moon. How much will a 20-pound object on Earth will weigh on the moon? So our keyword, the one that keeps us in, that tells us that this is a variation problem, is this part, the very first sentence. The weight of an object is directly proportional to the weight on the moon. So we're going to do some direct variation. So going to be y is equal to k times x. In this case, I kind of like specializing the formula to fit the problem. So instead of Y, I put E, stands for Earth, K is still the constant, and M instead of X to stand for the moon. Because from sometimes you kind of forget which one is your X and which one is your Y when you're translating a word problem into the formula. So it's good to specialize your formula, but still keeping the formula. It's still going to be multiplying right here, and it's still going to be a single constant number on your left hand side. Okay, you're not putting addition sign, subtraction sign. You get it, right? Still the same format. So now we're going to substitute our first two numbers. In this case, it's 200 pounds on Earth, so E is equal to 200, and 32 on the moon, so M is equal to 32. Substitute those two numbers, you're going to get 200 is equal to K times 32. Solve for K, all these things, yada yada yada, and you're going to get 25 over 4 is equals to K, and that's okay. As I said previously, it's okay to have fractions on your K, because sometimes there's just nothing we can do, and sometimes it's better to leave it as a fraction, because sometimes you get repeating decimals. If you change this, you probably get like a long decimals, and that's something we want to avoid. So let's just keep it as fraction. Now we're going to substitute this K and our third number, in this case 20 objects on the Earth, so 20 equals to 20 into our formula. So it's going to be 20 is equals to 25 over 4 times M. You cannot see that this part is way different from our second part, or first example and our second example, because the unknown is inside the fraction and inside the right hand side. Most of the time it was in the left hand side. In this case, it's the right hand side. So what do we do? Well, you guys learn topic 8, right? You learn how to solve equation, and you basically do the same thing with this one. You're going to isolate M. How do you do that? Well, you have to get rid of that multiplication, 25 over 4. So you divide both sides by 25 over 4, and you're going to get, if you do your fractions, if you know how to do your fractions, you're supposed to be able to do this. 20 over 25 over 4 should give you guys 16 over 5. This two fraction cancels out, you're left with M. So M is equal to 16 over 5 pounds. Again, word problems equals units required. We cannot just say 16 over 5, we need to say what kind of 16 over 5 is it. And again, as you can see, it's okay, it's perfectly fine to have fraction as your answers. You don't need to change that to mixed numbers, decimals, but I do want you guys to change that to lowest term if possible. Now let's move on. Okay, I have two. I have two questions of the same thing. So let's try another example. The distance of a spring stretches directly proportional to the force applied. If a 6-pound force stretches a spring 18 to 18 inches, how far will a 2-pound force stretch it? So again, that's our first sentence should key us into what are we going to do. It's going to do some direct proportional or direct variation. So it's going to be y is equal to k times x. In this case, I want to specialize it again to fit the word problem. So it's going to be S is equal to K times F. S is for spring and F is equal to force. Why did I choose that? How did I get this 2 from here? Well, right here, 6-pound force. Well, that part should click in your brain that force might be important in this problem. And then this part is the string stretches, and then string to 18 inches. String that part should also key as in that springs should play a vital role in this problem. So I say S right here. But you might say, sir, won't it be F is equal to K times S because 16 force and then spring is on the later half of this sentence? Well, I'll argue that you're supposed to look at the first sentence instead of the other sentence first. So in the first sentence, we're talking about spring and then force. So it's going to be spring and then force. Same thing with the numbers on the previous slide. Earth and then moon. And then where's the moon? And then moon. So Earth and then moon. You cannot see it, right? Hopefully you see it. So now we identify is directly proportional, direct variation. It's going to be y is equal to k times x. Change that to s is equal to k times f. And use the first two numbers that's given to us. It's going to be 6-pound force and 18 inches. Substitute that, you're going to get 18 is equal to k times 6, and then we solve for k as shown as here, and you're going to be shown as 18 over 6, or again you can simplify. I want you guys to simplify that to 3 is equal to k. Now we're going to use this k and our last given number f, 2-pound force, f is equal to 2, and rewrite the formula as s is equal to 3 times 2, and then solve for the unknown. In this case, 6, or not just any 6, is going to be 6 inches. So that's it for variation. Hopefully you learned a lot, and then we're going to talk next video. We're going to talk about word problems, mixtures, and solutions. Goodbye.